So we are in chapter 8. We're going to finish this up, and it'll be fun. So here we go. The last section is talking about proportions. Proportions means like percentages, proportions, that kind of thing. Let me make this a little less thick. And that's why they're using P. They're using the P. P for percentage, proportion, that kind of thing. And doesn't it look kind of interesting here? Oh, probability. That's another one. Look, probability. They all start with probability. What? Chad, you can't spell today? Probability. Anyways, notice right here, you could actually say that this is selected over total. Haven't we already seen that before? So it's all kind of coming together, the same thing. And this Q is equal to 1 minus P. That's just your opposite. And again, we've already seen that as well. So if I say 70%, the opposite of that would be 30%. If I said 55%, the opposite would be 45%. Exactly. So they're just the opposites. Cool. Okay. So we got 102 plan to join the armed forces out of a total of 867. What is P? Wow, no, it's probably 102 over the 867. Yay! Calculator. So I'm going to use some Desmos real quick to get some simple answers. So here we go. Scientific. Is my mouse acting weird today? Okay, so 102, 867. What I'm doing right now is actually sometimes required. Now, most of the time, GeoGebra will kind of do this automatically for you. Like when you put in the decimals, or the fractions, it'll automatically turn to decimal. But it is important to still be able to do this once in a while. So what would be the opposite of 11.7? Exactly. So we're going to do 1 minus my answer, or 1 minus that amount, and we can get that amount. So 1 minus. Does it make sense? Let the calculator do it for you. Hello. Good with that? Good math? Okay, so we're just dividing. I mean, gosh, Chad, we've done that back in like chapter 3. I know. Nothing new there. Any questions before I keep cruising? We're good? Just divide. So, this is an interesting little side note here. Normally, we have the magic number 30, and I say n must be greater than or equal to 30 to kind of like, say we have enough. Well, the way they say it here is that n times p, or n times q, has got to be greater than or equal to 5. That's kind of the new number for them. But we only use that in this one section, and then we'll never see it again. So they have this really cool formula. Doesn't that look so awesome, guys? GeoGebra. And our familiar numbers that we have seen before and we will continue to use, depending. We're going to be asked for minimum sample size sometimes, and we'll have to use these guys once again, okay? So, all right, here we go. A real problem. Wow. So in a recent survey, we got this and that much. Very dissatisfied. Assuming normal distribution, find the point estimate and standard error for the proportion. Blah, 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 blah. Okay, that's fine. So here we go. 135 over the 450. And we get an answer. Yay, Chad, that was so awesome. The part that I don't know is how to get the next part. He doesn't know how to get the second part of this question. I don't know. Hello. So yeah, I have an idea. I'm going to go look at the workbook and see what it says. This is such a small and insignificant question, but we have to do it because it is going to be on the homework. Are y'all okay dividing? I'm not worried about that. Let's find this sigma thing. So up here, do they have a formula for sigma? Anything up here? Okay, well, you know what, guys? We're going to go to GeoGebra and hope for the best. I think that it's just going to be like a square rooty thing. I can't really, you know what? Actually, I do know the answer, but I can't believe they don't have the formula. That makes me super sad, bro. All right, let's see if I can do it without a formula. So I'm going to do probability, and then we're going to go to the statistics, if you remember how this works. Oh, let me do that over here. Okay, so we're going to go to the statistics, and I want to go to proportions. Z estimate of a proportion. I think that this will give it to you automatically, and so let's just see what it says. So click. Yep, I think so. I think that S sub B is what we're looking for. So I don't know about the confidence interval. They didn't really say anything, but we do have the successes, and we do have this thing here, the total. And so S sub B, there we go. And I think that's going to be it. But let me just check. If I change this to 90, you see how it didn't change? Look at the SE. So I'm going to change this now back to 95. See how SE did not change? Because it's not dependent on that. And they didn't tell us anything here. In a way, I'm trying to prove that I believe the answer is done. We just looked for the SE in GeoGebra. Now, are we cool with that? Are we done? Look, did they have the other thing here? Look, 0.3. There's your 0.3 if you really want GeoGebra to do that for you too. I don't think you need to do that. It's pretty easy just to divide, but whatever. Cool. Can I try to do it by hand right quick? I know I'm being recorded. I'll totally mess this up, but I want to try, okay? Basically, I think I remember the formula. So I think it's P times Q times, and I think it's like the square root of something over N. I'm trying to remember it now. PQ, something square root of N. Let me look around. Oh, maybe it's this guy. Maybe it's that guy. Ooh, yeah, that's what it is. That's what it is. Watch this, guys. They didn't really have a formula, but they did. Okay, was that the same thing? Okay, let me try this, okay? I'm going to try this. Y'all don't have to do this. This is just me being silly, okay? Silly Chad, what are you doing up there? Nothing. Not doing nothing. 450. There it is. Boom! Yeah, it works. So, yeah, there's your formula. If you really like formulas, there you go. Or GeoGebra. Right? GeoGebra would do it for you. Hello. Okay. Let me pull GeoGebra back up. Where are you? There you are. Okay. So I recommend using GeoGebra. Y'all cool with that? All right. Awesome. And that was the one question. You'll see it on the homework, but it won't be a big deal. All right. Now the real ones. In a survey of this many 3,000 adults, 1,400? No, 1,400. 1,400. That's how you say it. 140. No. 1,400 say they started paying bills online. 99% confidence about what's going on. So we're saying now that we have a survey of 3,000 people. It's pretty good, right? I mean, that's definitely more than 30. And now I'm wondering what's going on for all of America. Is all of America 3,000? No, all of America is like 300 million. So I can't survey everybody on that, but I can definitely do 3,000. I want to be 99% sure about how many people are doing their bills online for all of America. So I'm going to put it in 99 1422 3014. And I sing to you on YouTube. Enter. I mean, that's it, right? We're done. So they're really looking for the lower and the upper, and that's it. Lower and upper. Again, I'm 99% sure, 99% confident that somewhere in there is the proportion of all Americans doing their bills online. Cool? Was it just that easy? Yes. Can y'all do that at the house later? Yes. Yes. You gonna pass this class? Yes. Yeah. No? Bro, do you need me to extend something? You know I'm very liberal in that regard. No, I said it online. Oh my gosh, I got recorded saying that? Did I just give extensions out to anybody who asks? It's true. So I don't mind. So with confidence. But which one of those two is the real answer? A, because population. There it is. There it is. Number 2. Fill it in. Number 2 pencil, that is. Number 2 pencil. There you go. Yep. Population. Again, we're looking for all of America. 99% confident about them. Awesome. All right. Oh, cool. Yeah, so 1,000 adults, 181 say Abe Lincoln was the greatest president. We got 90% confidence, blah, blah, blah. Here we go. How many presidents have we had? Hasn't it been like 50-somethings now? 40-somethings? Yeah, so it's a lot of choices now, I guess. I thought Abe Lincoln would be a little higher, but, it's cool. It's cool, man. We got other choices now. Trying to think of some random one. Like, like a one-year president. Oh, 47? Okay. Today. Yes, today is the day. Yes. Yeah. So I'm going to put it in 90%. We got 181 for Abe Lincoln. We got 106. And there's your answer. So lower, upper. So I surveyed 1,000 people. That's pretty good. And I'm saying for all of America, the percentage of folks that would say Abe Lincoln's the best president would be somewhere between 16 and 20%, basically. 90% sure about that. I don't know. Like you're saying, hey, what did you do? You did GeoGebra. There you go. I mean, it is good to actually say where we went, Z estimate of a proportion. I don't know. You should be taking at least some notes like that, right? Cool. All right, cool. Oh, look. Yay! Right? That's what they were trying to say there. We did it. Yay. Keep scrolling. Okay. Do you consider air travel to be safe? Do you? You do? It's no problem, right? The plane will stay flying. Okay. Am I the only weird one? I'd rather be in a plane than a helicopter, okay? Helicopters, man. You get like the little rotor stops and you're just woof. Or you'll be spinning while going down. Okay, so I have 1,045, 99% confidence, and they're wanting to know about U.S. adults. And see how our little picture here has United States? Bam. Cool? Okay, so that's what we're going to do. So here we go. I got 99. My total is 1045. And so my successes, right, they're wanting, what do I put, like 69? Is that good enough? Okay. Right, it's got to be a percentage, right? 0.69, of course. I got a negative. Is that a good number? They're very much not confident. What do I put in for successes? Normally, if you go back up, we actually had a whole number for Abe Lincoln. Does it make sense? So I need a whole number, like a actual bigger number than just this. How do we find that? Already got it. I wonder why, like, I even have a job, because y'all already got it. You multiply them. I'm going to do this on the side once, and then I'll show you that GeoGebra will pretty much do it all for you. So that should then be 721.05. That's our amount that we're going to be looking for. This one. Yep. Okay. So 721.05. I mean, really, you're just 721, really. And so lower and upper, here we go. 0.6531, 7269, and there we go. That's how you do it. Cool. Now, can GeoGebra do this for you? Yes. So I'm going to actually, I think I have to expand this a little bit to make it bigger. I don't know if this will work. Here we go. I got 1045, right? and then times the 0.69. You see how I put that in there? I just like literally put it in there and I got the right answers, didn't I? Same answers. Okay, but when I click off of it, okay, so they're doing it automatically for you. You do not need to do it on the side. It's done for you. Cool? Okay, so that's how that works. We're going to keep doing that going forward. Ah, yes, minimum sample size. So we have to do something by hand. Otherwise, what is this? This is a MATH class, right? So we got to do some of that stuff. And I think that Newton has a very interesting take on this side of things. Most of the time, if not all, we're going to be using this 50-50 rule. Okay, I'm going to explain it here in a second, but know if all of America X, Y, and Z. Okay, so we're gonna here's a perfect one right here. 90% confident, and you want to know the population proportion of people who refuse to eat leftovers. Okay, and so you want to be within 2% of the actual proportion. How many people do you sample? Okay, so I want to know. They're like, okay, I want to know with 90% confidence. I want to go on the news and say, hey, look, this many people don't like leftovers. So how do I get about doing that? How many people do I need to survey to get that? Does it make sense? Do I survey, 10? Is that good enough? Magic number 30, right? Maybe a little bit more, and that's what we're going to find out here. So there's your formula. Doesn't that look like an awesome formula? Gosh, so gross. So what I'm going to do is rewrite it a little bit better. So it's Z. Did they have a square on that? Oh, I hate that. No, never mind. Let me redo this. It's P times Q times, that's supposed to be a times, and then we got Z over E all squared. So that's the way I normally used to do it, at least. I don't know how Newton does it. All right. So how does this work? I'm going to start putting it in manually, and then I'll show you a little bit more about this stuff here in a minute. So P and Q. If you read here, it says the formula assumes that you have these values. But if you don't, use 50-50. So I'm just going to do what it says, and then I'll explain it here in a second. So I'm going to use 50-50. And then I need a Z for all this stuff. And then it says within 2%. 2%. So what I'm lacking is that Z right there. Are y'all okay so far with plugging it into the formula? 50-50 is 2.2. So we're lacking a Z. And that comes from, again, that 90% confidence interval, right? But we need to put that in somewhere. Where did I see a little chart with like Z's and stuff? You remember that? Did we see that earlier? Scroll, scroll, scroll. Scroll, 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 scroll. Scroll, scroll, scroll. What? Like this should be on a note card. 90% confidence. This is your Z. Okay? 90% confidence. That's what my Z is. So 1.645. Pop it in. Y'all are going to answer it next time. I'm going to say, hey, what's Z equal to? And you're going to say whatever I ask for, actually. Calculator. Dun, 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 dun. Here we go. 0.5 times 0.5, just following the rules. And I got 1691.265. I'm going to say there's a rare chance that we get to do this, but we actually have to round up. Okay? In this particular case. Are y'all okay with the math? Is the math okay? Oh, look, it's a receipt for pizza. He like said I had to take it. I don't know why. Okay, we're done. Sorry, guys. Sorry, that was on a recording. My bad. Anyways, good with the math? Good. Okay, so why do we round up? Think about it for a second. You want to tell me? Yeah, I'm I'm gonna start surveying you about your leftovers. Okay, here's my survey for the leftovers, right? And then you're starting to scribble in it. No, it's mine now. You just did 26% of it. Right? That would be dumb. Just let you finish up the survey. That's your answer for that. Now, this is if no preliminary estimate is available. This is the first time anyone's ever thought, hey, let's go survey people about leftovers. That sounds legitimate, right? So I have no past data. I mean, here, let's start this right now. Do you eat leftovers? Yes, yes, yeah, no, yes, maybe. Cool. Okay, I do too. I eat leftovers. But like, so I'm gonna do my preliminary research has said that 80% of Americans are okay with leftovers. Does that make sense? What I'm trying? Yeah, it's kind of weird. But like, I'd have to do something first in order to know. I have no idea right now. I have no idea. That's what they're trying to say. So how can we be safe? How can we get the correct numbers? How can we be most not political, but conservative with our numbers, right? How can we just like get a more solid number, I guess you can say, yeah? So what I'm going to do is 50-50. What it's actually doing mathematically is it's maximizing your minimum. Kind of weird, right? So like it says minimum, but we're trying to maximize because we're wanting to be extra sure. I'd rather do have a part B? Oh, there we go. So let's just say now it says 11%. Somehow, somewhere, we found like a few years ago somebody did this, and I want to redo it now. I now have 11%. 11% is my number, not 50-50 anymore. So I got 11. What's the opposite of 11? 89. And notice what just happened to my answer. I'm going to write this down. Notice what happened to my numbers. What happened? Yeah, it's much smaller. Yeah, we got 662.29, so 663 people to survey. Easier, that kind of thing. So we look at past data. We say, it'll probably people to know. But can I do some extremes for you? So let's just say people really, what is that, 11 people refuse to eat leftovers? Let's say I'm going to go 1%. And the opposite of 1% is 99. If it's so extreme that like everyone eats leftovers or nobody eats leftovers, okay, then how many people do I really have to survey? Not many anymore, because I'm going to get a pretty good idea real quick, like, that ain't nobody going to do this, or everybody does this. Right? Here's an awesome real world situation. Bluebell, they're looking for a new ice cream flavor. That's right, it's called pickle. That's right, pickle. And so, you know what would be better is to add chocolate with it. That sounds great, right? 99 says no. I don't have to go and have a lot of people surveyed on this, right? I can pretty much figure out right now how many people are really going to be buying that ice cream. Cool? That's the idea. The more extreme, the less people you need to survey. But 50-50, if I have no clue, will maximize that number. Okay, so what happened to it? It went down. I don't know. It went down. I just spent like 15 minutes talking about it, and it concludes with went down. All right, my job is so obsolete. Trying to justify my job somehow, guys. That was it? Are you kidding me, bro? Would you like me to go to the homework for a little bit and see what they have? Yeah, okay, let's do it. One yes means a yes. I would like to do that. what Newton does on this homework for the minimum sample size, I believe it almost always uses the 50-50 rule. I'm not sure if they ever not use the 50-50 rule, so we'll see. Okay. And here we go. Okay. Ah, yes. Yes. We've done this problem before, guys. Oh, it doesn't matter what my confidence is. It doesn't matter because I'm just looking for other things. Okay, I got a couple numbers up there now. What would be my successes? 56, what's my total? What happened to 8? It doesn't matter, yeah. So this guy is actually right here. I know I can go and do that on the side. I can use just the basic calculator, just to divide, just divide them. But GeoGebra does that too, so I might as well. And then this guy was my SE. I sure hope this works, because I just promised you it would. Oh, really? Yay! Ah, they're gonna get me 5-0, right? Yeah. Here we go. I don't think you have to put the 0. Look, there's that formula. We found it. Oh, standard error. Standard error. It's like right there. How nice of them. Are y'all okay with what we're doing here? Happy days, right? Would you have rather had taken algebra? I told my algebra class, I was like, and then they're getting ready for a test. We do have other math classes besides algebra, And I said, huh? Yeah. Oh, they're good. Was it 13-14 or 14-14? Did you get to use Desmos? No? Oh, that sucks. With who did you take that? Desmos, man, for everything. Anyways, yeah, I don't know what a little calculator even looks like. Yeah, that's actually really sad. Yes. The TI. Oh no, no, that's bad. I mean, we used to do that back in the 80s. But I think we've grown a little bit more from that. I don't know why. Why would they have done that? Desmos Matrix does all that stuff for you automatically. It's so nice. Yeah, I'm sorry for your experience. It's not okay, but confetti in this class, yay! Have y'all ever noticed that these are kind of confusing? They're always like the wrong numbers, because this is actually 80%, and this is, oh, I can't remember that one, but that's 90, yeah, 95, 98, and 99. Yeah, I don't know why they don't put these simple numbers up here. It's really dumb. Anyways, so here we go. We got 99% confidence, 76, and 350. And we got this guy was my 0.217, 3 decimals. Standard error. Cool. This guy, he's the z-score for 99%. 99%. I know it doesn't say it, but it's this 2.576 number. And you'd almost have to go back to the workbook to see that. I'm going to pull that up if you don't mind for just a second here. We go back. This one's way better. So 99, 2.576. Because that's what we actually should be using there. So 2.576. I mean, they just want you to say, hey, look, can you go get it? I guess. And then this is the lower and the upper, which we already have. So the 160, 3 decimals. And then the 274. So I didn't have to do any MATH on this, did we? That foul 4-letter word. It's okay. Chapter 9's looming. A, B, or C? Which one? B. Yep. 99% confidence. You can see that these two say it, but this one doesn't. So that's definitely one of these top two. And then true means, oh, right there, population. True population. If they use either one of those, it's correct. There we go. Cool, cool. Oh, this is the minimum sample size. Yep. Okay, we actually have to do some real math? Wow, I'm so excited. Real quick, let me pull up some blank paper here. I say paper, but you know what I mean. Oh, okay, and there we go. So this is the minimum sample size. We got P times Q times Z over E all squared. And so suppose a shoe store, this and that. We got 90% confidence. So 90, do you remember what the Z-score is for 90? 1.645. Have you memorized that? Good! That's awesome. It says within 3 percentage points. I believe that they want you to do this. I could be wrong, but we're going to double check it, okay? I think that's what they mean by 3 percentage points, is 3%. But again, do you see any other numbers? Did they give us a preliminary report? No. So what do I have to use? Yeah, 50-50, 0.5, exactly. 50-50. And I think that's how this is going to keep rolling the entire time. Yeah, I need to get some calculator out. .645, 0.03, all squared. And we're going to round up. 751.67. Well, I guess that would round anyways. Okay, awesome. 752. Let's try it out. Here we go. 752. Hit it. Yeah. And look at all that blah blah they're doing. That's the same blah blah we did. Isn't it? They just have a lot more little bloop bloop and ooh. I don't know. Sound effects included. So, same thing here. And I can do it again. I don't mind doing it again. 50-50 since they don't say nothing. Ah, Newton. So happy that, you know. What's 98% confidence? You remember? Oh, dang. I only knew 2.33, but you're right. That's awesome. Did you memorize that one too? Oh. Thank you. You're right. Yeah, it's right there. 2.33, 2.326. Yes. I know. So true. So true. That's good. I like that. Oh, that's a 425. But anyways, we're going to round up anyways. So here's the true test. Do they want us to round up? They do. Do they say round up? Oh yeah, look at that. Round the answer up. I know what I'm talking about. I know what I'm talking about once in a while. Yay! They pay me to do this. Thank you. Y'all pay me to do this. Okay. We've already done this one. Are y'all okay with this kind of stuff? I'm getting kind of bored. So, instructor sheet. Yeah. Man, don't you want that button for yourself? Yeah. Confidence, true proportion, or true population. There you go. Last one, minimum sample size. Oh, whoa. This. I had forgotten about this problem. Now let's talk about it. All right. They're wanting to discover what is wrong with their calculations. Okay? They're saying something up here is wrong, and we have to give the number for what is wrong. Okay? That's it. Okay, so 95% confidence. The wrong Z-score. There you go. So yeah, 50-50, again, because we don't have any other information. 5%, 5%. So yeah, this right here, that is for 90. There's 90, isn't it? Is that the one for 90? And 90. So yeah, this is 90. This is 99. So basically, they used the wrong z-score, right? This number here, right? It should have been this number here. So what they're saying is that we need to put in what they did wrong, I think. Which value of the calculation is incorrect? The 1.645. That's what's wrong. That number should be different. See? They're just saying what number up here should not be there. That was it? Oh, okay. Oh, it's just multiple choice of the same thing? I want to do this one. That'll be fun. Let's try it out. I mean, it looks different, so it makes me feel like, oh, we're going to do something fun. Okay, so yeah, 0.5, 0.5, and then we have, for 95%, what is my z-score? Nice. Within 5 percentage points. That dude. Right? Cool. Blah, 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 blah. We did it. We got time? We got literally 45 more minutes. Okay, 30. Okay. I would love to start chapter 9. Like I said, we're on track now-ish. Kind of. So, let's do it, man. Let's do some chapter 9. It'll be so fun. And it actually does start really simple. 9.1 is almost all definitions, and then we're going to move on to bigger things. 9.2, 9.3 is the real math, okay? So, I want to do a discussion, a talk, before we get started on this. I want to do a brand new thing here. Let's do that. That's great right there. So hypothesis testing, refresh, and then we can talk about it. Hypothesis testing. This is all of chapter 9. We're just going to talk briefly here. Okay. What we're trying to do in this chapter is make a claim. That's a keyword, claim, and then we're going to test against it, okay, or test for it, and then we're going to see if it's right or wrong. And so the keyword that we're going to be doing is a claim. That is a keyword. You'll see that all over the place. But now in this particular class, they limit it down to a very specific place. I'll show you what that means, okay? Now, the other side of it is that we have this claim, but the other side is, I guess, kind of like the status quo. They don't use that word. They do, what is the key word? Yeah, see, status quo. Null hypothesis. Okay, so null hypothesis. I didn't spell it right. Hold on. I gotta be like a little bit better than that. Null hypothesis is basically your status quo. And I'm going to use the same thing probably a bazillion times. Here we go. 50% of Americans are female. There you go. Status quo, right? Everybody knows that. It's not a big deal. But what I'm wanting to do now is test against it, right? Haven't we said, or haven't we seen that, well, I die early. Right? So, I know, I'm a goner, bro. You too. So, it's more probable for females to live longer. So, are 50% of Americans really female, or is it something else? And so that's my claim. I'm going to say, I don't think that's right. I think 51, 52% of Americans are female. Or perhaps I could just say, it's not 50%. It's more than 50%. That kind of stuff, okay? And so that's how we're going to approach this. So null hypothesis. The claim is what would be this alternative hypothesis. I can't do hypothesis apparently. And so they got these little subscripts. We got H naught. I'm going to write it out. H naught. It's a little O down there. It means not. And then this is called H sub A. H sub A. Where's my eraser? So this is H sub A. Okay. Or just alternative. whatever one you want to do. Like alternative hypothesis. I do H sub A. So one semester, someone had a really fun way of saying it. We got the ho and the ha, and there was like a lot of laughter about that kind of thing. You can take it as you like. Okay, we made up stories too, but that would not be good for recordings. You can only imagine. Anyways, so I don't really know what goes in all these boxes right here. Yeah, I can tell you that this is the null and this is alternative. I can at least tell you that much. And so the distinction between them is, at least for this class, is going to be if they have an equal sign or they don't have an equal sign. So notice right here, these guys are very important, okay? So this one has an equal sign in some way. Notice doesn't have less than or equal, greater than or equal, right? So that always has an equal sign. This guy does not have an equal sign, does not have an equal sign. And you can see that right here with these guys, less than, greater than, not equal to, okay? And so we're always going to be opposite of one another. They're always contenders against one another. We do this here. So you can see what we have for these options. If we have less than or equal to, the opposite would be greater than. Greater than or equal to is less than. Equal to, the opposite is not equal to. And in this class, it's always the bottom that is going to be the claim. In this class, you take this class again here next fall, it's not going to be that way anymore. We're changing programs. It's going to be a whole different setup, and we actually get back to the harder math. But for now, we got the simple math, and the bottom is always the claim. Okay, and I'm going to write claim on the bottom because I'm just so used to it. Okay. So H naught always has a symbol with an equal in it. See, that's what I was talking about earlier. Blah 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 blah. Okay, cool. Okay, so let's go through some of these and just do some examples. And this is a nice setup. We'll get to talk about it, and eventually we'll start doing math with this stuff. So, Georgia is a high school senior. Read an article. Only 49% of teens have a driver's license. She claims that the percentage is less for students at her school. So what would it look like? What would the null and alternative hypothesis look like? First off, I'll tell you, we're going to start with a P. Don't we have a percentage right here? Now notice that up here they had this mu. This stands for mean. But here we have a P, so that's going to be a proportion. So we're going to use a P for that stuff, okay? So P. Now she's saying less. Is that less right there? Less. And less by what? Less than what? Yes. Number-wise, 49, very good. And again, that's a claim. I'm going to keep writing that at the bottom. You don't have to use parentheses, but that's the claim. So then, out of these three options up here, which one makes the most sense for the null hypothesis? What should I put here? Greater than or equal to. It's got to be the opposite of that guy, right? They're always literal opposites. 100% opposites, okay? I don't know what's going on here. Go away. Now, I do have to say, we're done. That was the end of that. Yay. But I do have to say that in GeoGebra, this is not in Newton. This is in GeoGebra. GeoGebra will have an equal sign up there always. And it looks kind of like this here. They'll always have an equal sign there. And it's true. There is always an equal sign in the top. It's just that it's kind of missing some of the point there, okay? So GeoGebra will not have you put that symbol in, but you can definitely put this symbol in. It'll be fine. It'll understand that. You get me? It's kind of like we already know that, but GeoGebra is a little silly. Okie dokie. So which is the claim? Yeah, the alternative. That's always. I'm just gonna write always. Always. If we encounter something here in the workbook that says otherwise, that's just the workbook being funny. Okay. In the reality, and for this class, it's always alternative. Okie dokie. Okay, cool. Was that hard? not so hard so much, but we haven't done any math yet. A recent study suggested that 75% of seniors take more one medication. A doctor who would like to know more about the percentage, whether this percentage is higher at whoever, whatever. Okay, am I going to use a P or a mu here? P for percentage. Awesome, awesome. P for proportion, probability, all that kind of stuff. Notice it says higher. That's his claim. Status quo. Doctor comes in and says blah, blah, higher. So what am I putting right here? Greater than what number? You got it. And that is the claim. That's him claiming something else. I think, the doctor's saying this, I think that there's more out there. Status quo said it was equal, or what should I actually be putting here? Less than or equal to, very good. But again, GeoGebra would say just straight equals. That's it. That's what we got. Wow. I mean, we're gonna keep going. I'm just saying, like, there's nothing else to talk about here. I would like to introduce more. I would. I think that we should. Can you give me a second? I'm gonna scroll ahead. Y'all, are y'all good here right now? I'm gonna scroll ahead. I want to see when they're gonna do the tail tests. Yeah, not those guys. Tell me right there. Tail tests. Yeah. I want to prepare you for the tail tests ahead of time. I think we got a lot of room. Look, we got room. I can do this. So I want to show you what tail tests are. Okay. So what I'm saying is tail tests. Tail test. And there's three options. We got left, right, and two. And so I'm going to draw a little mini picture for each one of these. I think that's going to be too big there. A little mini picture for each one of these. So left tail test. Give me a bell curve, bro. Yeah, it's close enough. Left tail test has a little tail on the left side. Right tail test. A right tail test will have it on the right side. Wow. And then a two tail test has it on both sides. Oh my gosh, you already know. How did you already know? Okay, this is how it works. When your H sub A uses the less than symbol, it'll be on the left side. When your H sub A uses the greater than symbol, it'll be on the right side. Yeah, and then finally, if H sub A says not equal to, it's on both sides. There you go. So I'm looking right here, and I want to know what kind of tail test I have. Yeah, that would be a right tail test. And I'm going to just draw a little mini picture each time to remind us what it looks like. What I'm doing is I'm saying 75% is, the status quo. I think it's more than that. I'm going to be looking on this side of the bell curve and seeing if it's going to fall on that side, if it makes sense over there, okay? And eventually I'm just going to do something like right tail test, kind of make it quicker. But they will ask for this. I'm just preparing you ahead of time since we have the room at the time. Cool? We'll see it again in a little bit. Okay, so let's keep going. Y'all cool with the tail tests? We will see it a bazillion times. You can't get away from this. It's like a preliminary thing. Okay, civil engineer is interested in a number of planning permits. It is known, status quo, regular, everybody knows this, African Americans are female, that the average number of planning permits submitted by a city is this much. Okay? Everybody knows that. Didn't you know that? Just joking. Oh, you did. Oh. After studying this further, the engineer believes, see, he's going to get his own say on it. He's going to be, wow, I couldn't have made that worse. He's going to be using a claim. He's going to claim something here in a few seconds, that the average number of planning permits submitted is different. There's the keywords, is different. So first off, am I going to use a P or a mu? A mu because it's mean, right? Didn't they say the word average somewhere? Right there, average. So we're going to use a mu. I think that Newton asks for that. I don't think they always put that. I think you have to choose that once in a while. anyways, is different. What should I then put for the claim? Not equal to. Kind of a little weird, but that happens. Not equal to the 760. So what do I put up here? Plain equals. Again, that's like my claim. Okay. And if I had to make a decision what kind of tail test, it's a both, two-tail test. You got it. Both sides. See, it says is different. What if it's less? What if it's more? Could be either. I don't know yet, but we're going to test both sides, and that's what we're going to be doing. So which is the claim? H sub A. Always. Always. In this class. You go to another statistics class, it'll be different, but in this class, always. Awesome. Cool? Doesn't seem too bad yet. We got time? We got a little bit of time for this. So type errors are honestly one of the harder concepts even for me. I'm trying to always understand exactly how I can do this right, but like teach it right. So there's a decision. I think it was a little bit off. There's a decision made, and then there's the actual truth that's going on. And a lot of times they use a court case thing. Do they have that in this one? Okay. I almost want to draw it so I could show you. I don't want to do this. I don't like that. So think about like a court situation. Let's say you're put on court, you're put on trial for a murder. Yeah. So the decision would be either you're going to jail forever or you're not, kind of thing, right? But then there's either you did actually murder someone or you did not actually murder someone. Does that make sense? So the idea is that there's something that we're making a decision about compared to reality. Yes? And what we try to do is mush them together. If you murder someone, you're going to jail forever. If you don't murder someone, you go and you're fine. Right? That's what we're trying to do. And that's what this correct decision thing is that if things are fine, then, we did the right thing. But what if you didn't murder, but you still went to prison? That would be an error. That would be a problem in our system, right? Same thing, if you did murder and you didn't go to prison, that would be an error. That would be a problem. Does it make sense? So that's kind of what they're trying to get at there, okay? The problem is kind of like which goes where, and I think this chart is going to be important for us to go use. Okay, so I'm gonna read through this, and we're just gonna kind of like decide which one, looking at the table. Okay. I still don't like that. Okay, so a company specializing in a parachute assembly states that the main parachute failure is not more than 1%. And that, okay, so far, the company is saying that their parachutes are awesome. The failure rate is not more than 1%. 1% or more fail, or well, less than 1%. Less than 1% fail, but not more than 1%. Still sounds pretty bad, right? Parachute, whee! You perform a hypothesis test to determine whether it's false. And so let's start setting this thing up. Like, I need to make a claim about this because they're saying something and we need to go against them. So they're saying not more than 1%. And I'm thinking it's false. So what would I put here? I know it's a P. And I know this is a 1%. So what would you put here for the alternative? A less than? You say it's less than 1%? No? To me, it looks like it might be the greater than, right? Because it would be 1% or more, basically. But then again, see how it says not more than? So it makes me feel like they're saying that status quo is that it's not more than, it's less than or equal to. No, not more than. Oh, yeah. Could it be 1%? Could it be a 1% failure rate? And they're okay with that? So the equal sign makes sense for them. They're okay with 1% failure rate? Not more than 1%? I know it's bad. I'm just saying, like, mathematically, 1%, would they still have made a true statement? 1% failure rate. Oh, it wasn't more than 1%. Okay, so then that's true. So then they're doing the equal sign. Does that make sense? Okay, so then ours is saying, no, it's greater than 1%. That's our claim. Okay, I'm just making sure that we're doing this right. Left, right, two-tail, what kind of test? What tail test? right tail test, right tail test. Again, we don't need to know that right now. I'm just setting us up for the future. Okay, so that's what we got. This is what we're looking at right now. We got this guy. Okay. When will a type 1 or type 2 error occur? And then they talk about the seriousness, but that in parachute land, I think that's important. Not with the murder thing. That's a different thing. So type 1. Let's do type 1. What's going to happen on Newton is going to be a whole bunch of blah words. It's all multiple choice. You click the one that sounds the best. And it's like really, there's a lot of confusing because it goes back and forth there. But let's try to do it correctly. Type 1. Type 1 is that we're going to reject H naught. And yet, I'm going to put like yet, H naught was true. So H naught is this guy. It's like the parachutes are good. I'm gonna write in other things. I'm gonna say parachutes are good, right? Good parachutes is what they're saying. Now the decision is that no, we don't think your parachutes are good, and yet it was good. Are you seeing that flow there? Because we're doing type 1, okay? Type 1. So I would say we reject that parachutes are good. That parachutes are good, yet they are good. Okay, so we go and say, nah, man, your parachutes are bad. But then, like, actually, they were good the whole time. There was no problem. So does that make sense what I'm trying to get at there? We made an incorrect decision, but what happened in the end? Is that an okay thing? I mean, at least was it terrible? I mean, I'm coming. You say no, you say yes. This is interesting. So I'm coming up to the company, parachute.com, and I'm saying, hey guys, your parachute's going to fail, man, blah, blah, blah. And I'm going to go on the blogs and all this stuff, but like really, and they just showed the data and are like, nah, it's okay. I know that we probably throw the company off a little bit, but like nobody died. Does that make sense? Type 2. So type 2, it says that we do not reject H naught. A way that I use in English, and this is not mathematical. No, not mathematical, but it's a Chad, and I'm going to use it all the time. I'm going to use the word support. Do not reject, support. Okay, right? That's what I would say. Support H naught. So I'm going to say, yeah, parachute's good. We like parachute good, and yet the parachutes were bad. So we support. I don't like that word, but it's okay. We're going to use that word for other stuff later. We support that parachutes are good. Yet they are bad. They are bad. Okay. So we go out there and say, right? That ain't good. So when they say like which is more serious, like I would say that's more serious in this particular case. Make sense? Okay, so how do I convert that into the homework? You click, you submit. That's what it looks like. Are y'all getting the flow of this here? I don't like the word support. I'm going to use the word accept. I bet it doesn't matter. You're going to see me say all kind of words. Words are cheap. Did you know that? Accept. I don't know. It's just Chad words. We'll use the word support as well and accept. Good? Don't really matter right now. I'm just using words. Okay. And look, we'll never see it again. Yay! Yeah, that was pretty much it. Blah, 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 blah. Okay, that was probably important, but I don't really know why. So. P-value. Love it. We'll have to do that here in a little bit. Do we have time? I don't think we have time for p-value. And then the type test. So we'll come back and talk about that here next time. The tail tests, I'm just going to emphasize again, we got the left tail. You can see right here, we're using this symbol to determine what the tail test is. Okay? And what this is going to do is tell us this thing called the rejection region. But again, we don't have enough time for that today, but we're going to be getting into the rejection region stuff later. Ah, look, it's an actual question. It says, this is all set up. What kind of tail test? And then we're going to go, you know what? Let's do the tail test. Is that okay? Let's just get this part done because it's really fun. I love this stuff. So blah, 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 blah. And they give this. Which tail test? Left tail test. Boom, done. Like that was it. That was all we have to look for. Done. Here, I'll even draw a little picture because, it looks cool. Yay, pictures. What about this guy? Right tail. Awesome. Number 2 pencil. Boop. Done. Hey, what does a right tail test look like? It looks like this. That was it. They don't have an actual one here. They just have words. So this is just us doing it just like normal. Okay. So consumer analyst reports the mean life for a certain automobile battery is not 74 months. We're going to set this up ourselves. I think this will be the last question of the day. Is that okay? Last question. So am I going to be doing a P or a mu? A mu, they're saying average, right? Then they say average, mean. There it is. And then 74. But what would be the claim? What would I put here? Yeah, not equal to. Therefore, on the top, I would put a equal to. Very good. This is the claim. And so, what kind of tail test is this going to be? 2 tail test. Very good. And so we got a little bit there and a little bit there. Awesome. Y'all are getting the hang of this. So when we come back, I'm going to go back over this p-value stuff. I don't think we have to talk about that right there, but they literally are jumping into it right here. P-value is so important. It's going to be huge. And I actually use p-value to bring blah p-value of this and that, and they understand what that means. Okay, it's an actual thing that you will encounter eventually in life. All right, we're good. Thank you guys. Y'all have a great day.